friends, this video on Semiconductors Part 2 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched Part 1 before going ahead with Part 2. Now, in order to understand what exactly happens what exactly differentiates a semiconductor from a conductor and insulator, we have to introduce the concept of energy band. Because now I have just told you the definition that semiconductors will conduct less, conductor will conduct more, and insulator will not conduct. But why should you believe me, right? I should be able to show you that how semiconductors conduct electricity, how insulators do not conduct electricity. So in order to understand that, we will have to introduce or we will have to take help of the energy band concept. Now, what is energy band? So that energy band itself is a new term for all of you. In order to understand energy band, we will spend a few minutes in reviewing what we have studied earlier. In one of our previous lessons, I guess in current electricity, we talked about the way a conductor carries current. How does a conductor carry current? You remember? It is because of the presence of free electrons that a conductor can carry current. So in this case, what happens when an external electric field is applied, the free electrons which are present in the copper atoms, in this case we have taken the metal as copper. So this free electrons start moving towards the positive end of the electric field, because electrons always move in a direction opposite to the direction of the electric field, right? So these electrons will start going towards the positive end. So, and this is how this movement of the electrons constitute the electric current. So that means if we want an object to be a conductor of electricity, what do we need? We need free electrons, because these free electrons are the ones which are not tightly bounded to the nucleus of the atom, right? We know this concept we have already studied. Let us quickly review. The valence electrons, that is the electrons which are present in the outermost shell, they are most loosely bound to the nucleus. So when a little amount of energy is supplied, that valence electron can be taken out from the atom, and then that valence electron becomes a free electron. And this free electron, when an external field is applied, will start moving towards the positive end of the electric field, or in a direction opposite to the electric field. And this flow of free electrons will constitute the electric current, right? So this is how a conductor behaves. Now we have told that semiconductors also conduct electricity, but lesser, but the level of conduction is lesser than conductor. What does that mean? I just told that semiconductors are intermediate between conductors and insulators. So now we will see in detail that what is the difference between the conductor and the semiconductor. Now, also from the quantum model of atom, you have studied this lesson on atom in your chemistry as well as in your physics lesson, right? So you all are aware of this, that the structure of every atom would look somewhat like this. You will have this nucleus in the middle, which will consist of the protons and the neutrons, and then the electrons will be revolving around it in different shells and subshells. So here if you see, the first orbital is 1s orbital, which is a spherical orbital. The next one is a 2s orbital, right? And then you have the 2p orbitals. So what are these orbitals? You all have studied all these things in your chemistry as well as physics lesson on atoms. So in case you want to review, please get back to those lessons and study the basics once again. So when I talk about this 1s, 2s, 3s, 4s, what are these? This 1, 2, 3, 4, they are nothing but the shells, right? When I say 1s, 2s, 2p, 3s, 3p, 4s, 4p. When I say 1s, and then in 2 we have 2s, 2p, in 3 we have 3s, 3p, 3d. What are these SPD? These are nothing but the subshells. So inside the shell you have subshells. Now again, when I talk about 2px, 2py, 2pz, I am talking about the different orientations of the p orbital. So what are these? These are the different orbitals. right? And the electrons are arranged in these subshells, orbitals and shells. So, and this is how the electrons are moving randomly around the nucleus. So this is the structure of one atom. Right now I am talking about one atom, right? And if we look at the energy of each of these energy levels, so that means the electrons are revolving in different energy levels. So when we look at their energy, we can see this 1s will have lesser energy than 2s, 2s in turn will have lesser energy than 2p, then 3s, 3p, 4s and so on. So this is how the energy is increasing with the different energy levels. So that means we are all convinced with the concept of energy levels. We all know that electrons revolve around the atoms and electrons are present in different energy levels, right? Even from the from Bohr's concept of hydrogen atom, what did he say? He said that whenever an electron tries to jump from an outer shell to an inner shell, then what happens? Energy is released. Similarly, when you try to excite an electron from a lower energy level to a higher energy level, that time the electron has to absorb some energy. So if you supply some energy to the electron will jump from an inner energy level to an outer energy level, or from a lower energy level to a higher energy level. So that means as you go higher, your energy increases. The energy level is increasing, right? So this is n is equal to 1 is the ground state. That is the state with minimum energy and therefore the most stable state. If I tell you, can you take out one electron from this shell? When you have electrons in n is equal to 2, n is equal to 3, n is equal to 4. You can't, because the electrons which are present in this energy level, they are the ones which are most tightly bound by the nucleus, because this energy level has minimum energy and therefore maximum stability. So as you go outside or as you go higher from the ground state, the energy increases. So we say we are going to higher energy levels. So in this line spectra of hydrogen, we saw that as the electrons were excited from different higher energy levels to a particular levels, we got these lines, Lyman, Balmer, Paschen, Brackett and Pfund. So this was an evidence. This entire concept, this entire theory given by Bohr was an experiment, was an evidence for the existence of energy levels. So we all are convinced with the fact that electrons exist in energy levels. Now here in this lesson, we are going to talk about objects. We are not talking about single atoms. So far I was talking about single atom, right? In a single atom, there are different energy levels. Now what will happen when a lot of atoms come together? Here, what I have shown is you have different elements. So different elements will have different kind of electronic configurations, correct? For example, hydrogen, it has only one electron. Helium, 2 electrons. Lithium, 2 electrons in the first energy level, and then in the next energy level you have just 1 electron. That means if you supply a little bit of energy, you will be able to extract this 1 electron, correct? Whereas if you look at oxygen, what happens? In the first energy level you have 2 electrons, and in the second energy level, how many electrons do you have? You have 1, 2, 3, 4, 5, 6. Do you think that if you apply a small amount of energy, you will be able to extract all of these 6 electrons? You will not be. Because here in case of lithium, there is just 1 electron which is present in the outermost shell, and therefore it is very less tightly bound to the nucleus. Whereas in case of oxygen, there are 6 electrons which are present in the outermost shell. So oxygen wants to be stable. And in order to be stable, it will prefer to take 2 electrons and become complete rather than giving away 6 electrons, right? Oxygen will be stable either he has the outer shell empty or he has the outer shell fully filled. So fully filled means it can have 8 electrons. So now already it has 6. So it is easier for oxygen to take 2 electrons and become stable. So oxygen will not like to lose all the 6 electrons, and it is not easy to bring out all the 6 electrons because you will need to supply a huge amount of energy. right? So the electronic configuration of each element plays a very important role in deciding how will that element react when you supply some external energy to that particular element, right? So that is one thing. So how each of the energy levels are, that depends on the electronic configuration of each of the elements. Now let us talk about a scenario where we have huge number of the same element. For example, in this case, I have taken so many different elements, out of which lithium, if you take example of lithium, there is only one electron in the outermost shell. If you supply a small amount of energy, it will go out. So that means you can very easily get a free electron. So lithium is a metal and it is a good conductor of electricity. Similarly, if you consider sodium, in sodium also if you see, the outermost shell has only one electron which can very easily go out. So again, sodium is also a metal and a good conductor of electricity. Correct? So similarly, if you look at nitrogen or oxygen, it is the opposite in case of nitrogen and oxygen. So they are not good conductors. So they are all insulators, right? I mean, in case of nitrogen and oxygen, I mean, you don't have that option. So they are not. So when I am talking about conductors, almost all metals are conductors, right? So in this case, when you look at the configuration of lithium or sodium, they are metals and their configuration is such that it is very easy to pull out a free electron. Now look at these two cases, silicon and germanium. As I mentioned, silicon and germanium have got some different characteristic or some unique behavior because of which they are neither conductors nor insulators. So they are the semiconductor. So what do you see? How many electrons are there in the outermost shell? There are 4 electrons in the outermost shell. So what do you think? They would like to, in order to be stable, silicon would like to gain electrons or lose electrons. If you think about it, for silicon, if it wants to be stable, it should either have 0 electron in the outermost shell or 8 electrons in the outermost shell. So right now it has 4 electrons. So for silicon, both the cases are similar. Either it loses 4 electrons or it takes 4 electrons. So both look similar. So silicon can opt for any of these. So now we will see in the next few slides what option does silicon choose to be stable. Okay. Now the question is, when I am talking about objects, in this lesson we are going to talk about objects. We are not talking about atoms. So in an object, what will happen? In an object, there are huge number of similar atoms, right? So what happens when a huge number of similar atoms come together? When they come closer to each other, what will happen? Here I have shown you one particular sodium atom or one particular silicon atom. But when so many atoms come closer to each other, what will happen? Let us suppose this is sodium. Sodium has its energy levels like this. Again, this sodium has its energy levels. Again, this sodium has its energy level. So that means as the sodium atoms try to come closer to each other, their energy levels or their outer energy levels at least, they will start overlapping with each other. Now what will be the result of this overlap? As a result of this overlap, there many energy levels will be generated which will be very close to each other. And these closely spaced energy levels is known as energy band. So energy band is nothing but large number of closely spaced energy levels. So energy band comes into picture only when we talk about a scenario where huge number of atoms are present together. Because energy, normally we have energy levels which are discrete, right? When I talk of sodium, I know that sodium has got energy levels and they are all discrete energy levels. The ground state corresponds to n is equal to 0, n is equal to 1, n is equal to 2 and so on. So it has got different energy levels. But when 2 or more sodium atoms come closer to each other, then the outermost energy levels, they will start overlapping with each other, and as a result of overlap, they will give rise to energy levels which are very closely spaced to each other. Now, these energy levels, which are extremely closely spaced to each other, is defined as an energy band. Now, this overlap of energy levels is something which you would have studied in your chemistry, where you all would have studied about the orbital theory, right? Molecular orbital theory, where there is overlap of molecular orbitals and atomic orbitals, things like that. So, all these, those concepts you have to study in chemistry. So in physics, we will look at the behavior of that object as a whole. So we will not get into their electronic configuration and atomic structure, right? So you understood this. What is energy band? Energy band is nothing but closely spaced energy levels. Energy band concept comes into picture when a large number of similar atoms come close to each other. Then their outermost shells or their energy levels start overlapping with each other, and this give rise to energy levels which are extremely closely spaced. So such energy levels which are very closely spaced together are known as energy bands. Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.